All right, guys, let's start off with our three-phase resistive load. With this one, we've got a three-phase source here, right? So we've got line 1, line 2, and line 3, and they're feeding what looks like a delta resistive load and another delta resistive load. Okay, what I've provided you with is the 600 volts. So between any of these lines here, there is 600 volts. Between line 1 and line 2, between line 2 and line 3, and with three-phase we have the exact same voltage between any of the lines. So we have 600 volts as our line voltage. So first step here, if we wanted to keep track of our steps, we can draw in our steps here. So first step is to bring that voltage right across. 600 volts on the line, 600 volts on the line. Okay, you can see that these guys are connected here, here, and here. So between here and here, we're also going to have 600 volts. Okay, that voltage is our line voltage going into each of the deltas. Now with a delta, what I want you to think of a delta as is a parallel circuit. Okay, so we're going to think of the Y as a series circuit, the delta as a parallel circuit, and here we know that V line is equal to V phase. In a parallel circuit, the voltage is the same. So what we can now do is we can drop in our phase voltage here. So second thing we can do is provide ourselves with the phase voltage of 600 volts. Okay, now that 600 volts, you can see is right here and right here. So you can see that this voltage, sorry guys, this voltage right here is 600 volts. And so this voltage right here is 600 volts as well. So we have 600 volts on the line, and inside of the circuit, we have 600 volts as the phase voltage. Okay, next step is we have 600 volts, and now we have the impedance on the phase. We have 75 volts on the first load, and we have 62 ohms on the second load. So here, each of these guys is 75 ohms. Every one of these guys is 75 ohms. Okay, balanced loads. I'll screw you up later by doing unbalanced loads, but let's try and keep it simple for now and just do balanced loads here. Okay, so all of the phase currents will be the same, and all of the line currents will be the same. Okay, next step is we're going to break all of these three-phase equations or three-phase circuits down into a simple Ohm's law circuit. So here we have 600 volts divided by 75 ohms. Here we've got 600 volts impressed across 62 ohms. Okay, for their first load, 600 divided by 75 gives you 8 amps. Okay, 600 divided by 62 gives you 9.67 amps. Okay, now on a delta, the current inside the circuit is always less than what's outside the circuit. So what you might want to do is you might want to draw in all your currents. That's our phase current. And we need to now find our line current. Again, the current on the inside of the circuit here is 8 amps. The current on the outside of the circuit is going to be higher. So this one is our step 4 here. And so we're going to take 8 amps and we're going to multiply that by root 3. So 8 amps times root 3 gives you 13.84 amps. Okay, again, fourth step here, we've got 9.67 amps as the phase current. We're going to multiply that by root 3 to give us our line current. And our line current ends up being 16.72 amps. Okay, it's always root 3 higher than the phase current. So we had 8 amps on the inside here. We have 13.84 amps as the line current. Okay, so for deltas, the voltage is the same because it's a parallel circuit. but the currents are all screwed up. They're screwed up by √3. The line current is always greater than the phase current. Okay, next step, if we wanted to finish these guys off, then step 5 here would be to find all of our powers. Okay, anything here is going to be equal to our line voltage. So we got 600 volts on the line times line current. Line current is 13.84 amps. And then remember that we have to √3 those values. Okay, don't forget to √3. And that gives me 4,365.92. Okay, so that gives you 4,365.92 watts. Okay, now remember that there's rounding issues there. So for the √3, I've probably used 1.732. So just be careful. Well, don't be careful, but it should match close to what you have. But you could have also used the phase values. 600 volts phase times 8 amps on the phase times 1, 2, 3 times 3. Okay, would give you a value very close to this guy here. Now, I just like using the same recipe all the time. So for this guy, I got 600 volts on the line times, what's my line current? 16.72. That's my line current, and my line current I have to multiply by √3. So 600 times 16.72 amps for my line current gives me 17,355. This guy is also watts. Each of these loads are resistive loads. Okay, we'll get crazy later on and we'll look at resistive loads and inductive loads, and resistive loads, inductive loads, and capacitive loads. But we'll do nice and slow here with 2 resistive 3-phase heaters here, connected in a delta. Okay, last step is we need to find our total line current. Well, these guys are both resistive loads, so they're in phase, right? Down here, the delta 3-phase loads are balanced. They're hooked up in parallel from the 3-phase source. Both loads are resistive, therefore their currents are in phase, and they can just be added together to determine your total source current. Now that note's not going to be there in a test, so we have to figure out the fact that this is a resistive load, this is a resistive load, and they're in phase. So we simply just add up these currents. 13.84 amps plus the 16.72 amps. And our total line current ends up being 30.56 amps. Okay, power total. Well, we've got 600 volts on the line. We just found that our total line current is 30.56 amps. Don't add up the phase currents. Add up the line currents. Phase currents could be in delta, could be in Y, right? We need to look at the line currents. The currents on these conductors here that are adding up. Okay, so we added those guys up. We found 30.56 amps. We're multiplying that by our line voltage of 600 volts times √3, and that gives us 31,720.92 watts. Okay, so we could just add up those values there. Okay, we look at the line currents and add them up as well. And really what we're trying to do is we're trying to just simplify this question from a 3-phase question into a single phase question. So we're dropping our line voltage to find our phase voltage, using the phase voltage and phase impedance to find our phase current. Then we have to use the fact that it's a delta, multiply that phase current by √3 to give us 13.84, phase current times √3 to give us 16.72. These guys are in phase, so we add them up and we get 30.56. Alright guys, I'll stop it there, and then we can you can go to the next video. The next video will be 3-phase resistive load, obviously number 2. Okay guys, before I let you go, I'm taking a look at these values, and they look messed because this guy here is 4,000 watts, right? And this guy's 17,000 watts, and this is 31,000 watts. This and this are supposed to add up together. So I don't know what I'm smoking here, but let's get rid of these values here for the wattage. I was using a different calculator, but it still doesn't excuse the fact that those values are totally wrong. Okay, so let's deal with the total power first. So we have 600, right, times root 3 times 30.56. That gives you 31,758.88. Okay, that's in watts. Okay, when we take a look at the first resistive load, we have 600 times root 3 times 13.84. And that gives us 14,000. So that value was totally wrong. I forgot the one in the front there. 14,382.9, if you round that up, 95 watts. Okay, again, as long as you're close to those values, but my values were completely wrong there. Okay, let's do the last one. 600 times root 3, so I'm using the full root 3, times 16.72 gives you 17,375.93 watts. Okay, so now let's see. We have 17,375.93 watts plus the 382.95. We're adding those guys together, and that gives me 31,758.88. So on these ones, this value and this value are supposed to add to give you this value. Okay, so quick and easy way, right? As soon as I saw that 4,000 and I saw this one at 17, I'm like, what's going on? They don't add up to this value right here. So you can quickly determine whether you've gone off the mark by making sure that this value and this value add to give you your total value. All right, thanks very much, guys.